Hey Miles, what's up?
Hey, Sagar, just calling to ask you for some help with some demonstrations that I've been asked to make for ATM. So my bosses are telling me I got to do something around AIOps, and I hear that you're the guy to talk about this.
Okay, sure. What would you like to hear?
Yeah, I think what I want to see is a little bit about the kind of prowess and the power that AI brings to the network administrators world. I've heard a lot about some very complex models that we've built and other things. Can you kind of show me through that?
Sure. I think I have a couple of interesting ones to show you. So let's go to Central, and as soon as you log in, this is the network health page, kind of an eagle's eye view of how your sites are doing, along with key performance indicators for each of them. And when you go to AI Insights, you have certain insights that are generated based on anomalies that the AI engine detects. And let me start with the outdoor clients insight, and that's one of my favorite ones. And would you imagine that it's actually the outdoor clients that are trying to connect to the network are in fact affecting the performance of your indoor corporate Wi-Fi clients?
Yeah, that's pretty interesting. So what you're saying is that, people passing by, whether it's a corporate site or a retailer site or whatever, are like latching on to indoor APs and eating up airtime.
Yeah, that's exactly what it does. So when clients connect at a very low SNR rate, they have a very low data rate, and what they end up doing is they end up hogging the entire bandwidth or increase the airtime utilization, giving less time for other wireless clients to talk to the network. And in this case, we are allowing the network admin with a optimization recommendation. What they're saying is change the probe threshold to 13, which is currently set to 0. What that will do is that will increase the signal strength at which the client should connect to the network. And this gives the power to the access point to reject authentication or probe requests from clients that are not supposed to connect to the network.
Wow. So that's a really like simple, direct kind of recommendation from this engine. But it seems like determining indoor versus outdoor clients could be very complex. It's not like we have the GPS data off the phones or anything. How is the network making that determination of what's indoor versus what's outdoor?
Yeah, I'm glad you asked, Miles. So what we use is a station positioning model, and this ML model, a lot of data is being fed into it. We are feeding in the SNR fingerprinting of clients every minute, every client that goes up to 1 billion records overall, right? And we are feeding this information into this ML model. It's looking at the SNR that the clients are connecting at. It's looking at what type of access point it is connecting at, and also what kind of client it is. And these are just a few that I named, but this model actually feeds in more than 15 variables to make this decision and identify if the client is either a passerby or an indoor stationary client.
That sounds really complex. Like I'm just imagining like 15 fields across and billions of records of just clients coming in on a regular basis that ultimately, what this model is doing is like analyzing every single one of them and making a determination of indoor or outdoor. Is that the correct understanding?
Yes, that's absolutely correct.
Wow.
And if you were to imagine that a network admin had to do this by themselves, they would have to start by taking packet captures, right? Understand and analyzing the probe thresholds, understanding what signal strength that the clients are connecting to the access points, and then tweak the probe threshold, perform the packet capture again. That's tweaking, and that takes a really long time, if not days, more than weeks. And still, you wouldn't have the accuracy which our AI model can bring to the table, which is more than 90% saying that yes, we know this is a indoor client versus a passerby client, and this is how you should change your probe threshold to have a better performance across your indoor Wi-Fi experience.
Yeah, that's crazy. Like you were just able to log in here and like, 30 seconds of clicking down into it, be able to determine what that SNR should be, and through a few other clicks in Central, you'd be able to go config and push that to the appropriate sites. So that's amazing. So this is an example of like an RF kind of insight, but it seems like there's issues across the network other than RF. So maybe an example of one of those would be really great for this demo.
Yeah, absolutely. So let me show you one of the insights that we have. And as you know, and you correctly pointed out, the network admins claim get blamed by just saying, "Oh, hey, the Wi-Fi sucks." But as we saw, Central can provide amazing recommendations on how to improvise your Wi-Fi. But not just that, we are also looking at connectivity insights. And the network admin didn't even know that is what it was actually a DNS. Part of their network that was affecting the performance.
Hmm. So what I'm looking at here is I'm looking at like performance over time of DNS, and I notice that there's a bunch of red bars, and you've got this class baseline thing, and then a blue line under it. So what's going on here? What do the red bars represent? What does the blue line represent? What's what?
Absolutely. So let me start by talking about what are baselines. Baselines are nothing but environment classifications that are AI and ML model, which is AI Insights, does for you. And let me show you start by showing you the company baseline. Now, what this does is this compares the DNS performance of this given site. And since we are at the Roseville site, it compares the performance across all the sites for the same customer. And as you can see, the data points that we've gathered for across the entire month, this is the DNS failure rate for this given data point, and you can see that it's okay. It's the company is the rest of the company is doing far better than this site. So network admin wouldn't have to worry about this one. But when you actually look at the class baseline, it compares this customer across all other customers which have exact or very similar deployment. And the environment classification is kind of very complex. It involves understanding what kind of APs that the customer has at a given site. Similarly, how are they using their access points? What kind of SSIDs do they have? What kind of client devices connect to the network? And then form a baseline by comparing the other peers in the same type of environment.
Yeah, that's really interesting. So I think what you're saying is you don't want to compare apples and oranges. Maybe an apple in this case is like an office and a high rise where there's a bunch of other networks around it, a lot of airtime utilization, maybe different AP models, to like a corporate office that's out in the middle of a field. They have a lot of control over their RF environment. Comparing those and trying to baseline against them wouldn't really be a great way to be able to do this, huh?
Absolutely. And I'll tell you why we are able to do that. We are able to do that because we have a very rich data set, right? 1.6 billion records, more than 65,000 customers, more than 1 million clients. And that is really helping us. The rich amount of data is helping us compare a retail store to a retail store and within a retail store across thousands of retail stores that they've deployed across the globe.
That's really cool. So based on this, it looks like this organization's DNS is performing worse than the baseline. How could these guys like figure out exactly what the issue is and start to drill into it?
Yeah, absolutely. So as you can see that we have an outage impact map here, kind of, so to speak. And if you look at the servers, you can start from here. These are the servers that have been picked as the top servers where we have recorded the DNS failures. And if you also look at the access points, these are the list of access points that are currently having the worst DNS performance. So of course, network admin has a queue where they need to start looking at.
Wow, that's pretty fantastic. So they're able to instantly drill down into what they need to start to look at to understand where the issue is and hopefully resolve it. Wow. So I think about a little bit about what some of our competitors are doing around this area and talking about AI and ML and all those other things. But I have a hard time understanding when you talk about 1.6 billion records, how they can kind of keep up with this. Sometimes the overall number of customers they have seems like it's way too small to be able to actually do this type of peer baselining, and way too small to even do some of the machine learning models. Just amazing me sometimes. Well, this has been a fantastic demonstration, man. I really appreciate it. It seems like we've got a lot of tools here to help network administrators save time.
Absolutely. At the end of the day, you want to reduce the mean time to innocence for your network admins.
Yeah, definitely, man. All right. Well, I'm definitely going to call you back up, put some calendar invites on your email, and we'll get this scheduled up so we can get it recorded for ATM.
Awesome. Sounds good, Miles.
All right. Have a good one.
You too. Take care.